Okay, we're going to analyze this question one more time. All right, and so this time, really what I just want to focus on is actually building functions, okay, for position, for y and for x, okay? And so the way that we're going to go about doing that is, again, we'll just kind of look at the stuff that we know, and we're going to use this equation here. Delta x equals v naught t plus 1/2 at squared. So we're going to build equations using that and using this one right here. Okay, so we're going to get equations for velocity and position for x and for y. That's the goal of this video, and that would be it. Okay, and so I'm going to do, let's see, I'll do this one for you, and then I'll have you do the next one. So if we are in if we have a horizontal projectile, if we're looking at vertical or horizontal displacement, then what we know is that the initial velocity horizontally is equal to 0. Sorry, not equal to 0. It's going to be, it was 30 meters per second. Okay. And then our acceleration, since it's horizontal, is equal to 0. Okay, so we get an equation for displacement. Horizontal displacement is going to be equal to 30 meters per second times t. Okay, and then you're going to see, yeah, so we have that one. Now I want you to go ahead and do this equation for velocity. You should get that it's equal to 30 meters per second plus 0 times t. So just v equals 30 meters per second. Okay, pretty straightforward. That's for x. And then over here for y, we're going to do the same thing. This time, I'm going to let you do the equation first. So delta y equals v naught t plus 1/2 at squared. Okay. So what's going to be our equation for y, or our function for y? Well, initial velocity is 0, 1/2, and this is negative 9.8 times t squared. So we get delta y equals negative 4.9 t squared. And then for vy, we know that the initial velocity for y is equal to 0. So I'm going to say vy equals negative 9.8 meters per second squared times t. Okay, and so now we have our set of equations for this, and we can just focus for now on these position equations. And one of the things that we can do with this can allow us to do things like use Desmos to model it. So the model that I used for this problem in the first video, I used these two functions to make it, and I'll show that to you now. So you can see right here, here's the x function, and here's the y function. Here I added 50, so it'd start up here at 50 instead of starting from 0, but everything else is just the same. And so I can now use these two functions to run this program that shows the motion of the projectile and also allows us to map the y and the x along those axes. Okay, and so this is one example of how this can be useful. That in itself isn't that big of a deal, but this becomes really useful in questions involving, like, so let's say, so a scenario that could potentially come up, and we're not going to really look at anything this complex right now, but let's say we have launched a projectile off of a cliff, and let's say that the hill that it's going to land on is sloped at some angle. Okay, and we want to know where the projectile is going to land. Well, this is much more difficult because we don't know exactly what delta y is going to be. And so having equations like this can allow us to figure this out, because we could basically like set up a ratio, like a trig ratio. Okay, and maybe we'll do one like this in class just so we can see how having those functions would make a question like this solvable. Okay, So the short video on just using functions for horizontal projectiles. We're not even really going to solve anything with it, but this is an important skill, and it's important for you to understand all the different ways that we can look at and model these things. Okay, if we were going to graph that x position, it would look like this. And if we're going to graph Vx versus t, it would look like this. Okay, if we're going to graph the y position, it's going to look like, well, really for that one, it would look like this. Or you could graph it like that. And then for Vy, it's going to start like this and have a negative acceleration. Okay, there we go. And really for these, just the more ways that you can understand to show them, to model them, the deeper your understanding is going to be. Okay?